Good day, viewers. You're welcome back to class. My name still remains Israel Egwai. In our discussion today, we are going to consider a very important part of chemistry, and it's mainly on periodic table. Remember, periodic table is one of the most important aspects of chemistry. Whether you like it or not, you definitely encounter questions here, both in your work and also in this your current Jamb that is coming in very not short distance. I will advise you to sit down properly, rest yourself, and try to understand. Because once you understand this basic part of chemistry, you don't have much problem. Because definitely, questions will come out from your periodic table. So please try and understand it. The question here says, explain the following factors as it affects elements in the periodic table: ionization energy, electronegativity, size of the atom, and hence the radius of the atom. Arrange the following in order of increasing size. Remember, all these topics are properly selected, so that by understanding this, you understand almost everything. And in the course of explaining this, we will explain almost everything in the periodic table. That's why I said you should try and settle down and try to understand. And again, we'll take our time to go into all these areas in order for you to succeed. Please, all we need from you, please, and I'm begging you, kindly subscribe, share it to your friends, share it please, and also press the like buttons, because the subscribers we are in need of is still very many, and the watching hours is still very many. Please kindly subscribe. God will continue to bless you. Now the first one is ionization energy. Ionization energy is the energy needed to set free an electron from an atom, a neutral atom actually, to become a positive charge ion, or ion with a positive charge. The energy required to knock off an electron from an atom, a neutral atom, to form an ion with a positive charge. For example, all the group 1, the group 2, the group 3, they all exhibit this ionization energy. Look at group 1, Na. You have 2, 8, 1. Remember, it's 11 now. Sodium is 11. When it releases electron, you have Na plus electron. It becomes 2, 8. As I said in the other video, remember, this 2, 8 does not affect the atomic number. Atomic number still remains 11. Number of proton is equal to the atomic number, still remain 11. It's only the number of electron on the shell, because it's the valence electron that it releases. It doesn't affect the number of proton. Atomic number still remain 11. So when you are still counting it, hydrogen, helium, lithium, beryllium, boron, it still stop at 11. So don't forget that. So this is the kind of reaction we talk about under ionization energy. Knock off electron from this, you now form an ion with a positive charge. Remember, this one is neutral. When it's neutral, number of protons is equal to number of electron. Atomic number is equal to number of electron. But once it release electron or absorb electron, it's no more the same. Let's go to group 2. This is group 1 because I have 1 electron in the valence shell. Let's go to magnesium. Mg282 is number 12. When this one release electron, Mg2 plus, use capital letter please. 2 plus 2 electron. The same thing affects group 3, Al283. It can release this 3 electron to any other element that needs it. You have Al3 plus 3 electron. So this is ionization energy. Now, how does it affect elements in the periodic table? Because you are releasing electron. To release a single electron is a bit difficult. What if you are releasing 2 electrons? It becomes more difficult. And you are releasing 3 electrons, become more difficult. You are releasing 4 electrons, become more and more difficult. And you know this one goes from left to right. For example, you have sodium at the same period. We are considering the same period, 281. You have magnesium, 282. You have aluminium, 283. You have carbon, you have silicon, 284, and so on and so forth. So to remove 1 electron is not easy. Talk less of removing 2, removing 3, removing 4. So ionization energy increases from left to right, because we are dealing with more electrons added to 1 shell. It's difficult. As you are removing more electrons, the energy becomes more and more. You need more energy to remove electrons. Don't forget, ionization energy increases increases from left to right to remove all the electrons. However, as you are going down the group, look at it. This is sodium, this is potassium. Potassium is 19, 2882. It belongs to period 4. 1, 2, 3, 4. You see it. The effective nuclear charge, the pull of the nucleus on the outermost electron, is no more strong. So this one can easily go off. So ionization energy decreases. The same thing applies to the rest because of the distance between the nucleus and the outermost electron, which is now becoming weakened. Therefore, it increases from left to right across the period and decreases down the group from top to bottom. That is ionization energy. The other one is electronegativity. Electronegativity. Electronegativity is the ability or power of an atom to attract electron towards itself. Ability to seize electron, to attract electrons towards itself. For example, let's consider oxygen. Oxygen 26 because it's number 8. It will need to put 2 electron. You see it? It need to put 2 electron to itself plus 2 electron to give you O2 minus. You see it? Then let's consider fluorine. Okay, nitrogen. Is it nitrogen? Oxygen. Let's just look at fluorine. Well, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Okay, oxygen, fluorine 27, which is 9, plus 1 electron. You have F minus. You see it? 2 8. This one 2 8. If you look at nitrogen, 5 2 5, which is 7, plus 3 electron to give you N3 minus 2 8. You look at it. This one require 3 electrons. To take 3 electrons is not that easy along the same period. This one needs only 2 electrons. This one needs only 1 electron. So it becomes easier to take 1 electron to add to this. That is why the halogens of which fluorine belong is the most electronegative element, because they just need only 1 electron. And again, because of the effective nuclear charge, it's just want to put 1 electron. It's not very difficult to put 1 electron. They become a bit more difficult to take two, just like ionization energy we just discussed. They become very more difficult to take 3. Therefore, electronegativity increases from left to right because of the attraction of the nucleus to the outermost electron, to the electron, to the outside electron. The attraction, we call it effective nuclear charge, pulling any electron it come across outside. So that is the effective nuclear charge, don't forget. So it increases from left to right because it becomes more easy. Remember, fluorine also, easy to remember, fluorine is the most electronegative element on earth. Now, we have talked about moving from left to right. Everything is from left to right, never from right to left. And remember, anyone that moves from left to right and increase, it does the opposite one down. So let's look at the one as it moves down. For example, we have seen fluorine. We said fluorine have only two shares. You see it? Let's go to chlorine. You see it? Chlorine have 3. 1. This one is 8, 2. This one is 7. 1, 2, 3, 4, 5, 6, 7. You see it? This one have only 2 shares. It can easily pull electron and seize it. This one have 3 shares. Period 3. The speed at which fluorine will pick electron because of the power of the nucleus, called effective nuclear charge, is a bit more powerful than that of chlorine. Then talk about bromine. You see it? The number of shares are now increasing. As it increases down the group, the ability to pull electron from outside become weakened. Therefore, electronegativity decreases down the group as the number of shares is increasing. Don't forget that. Electronegativity increases from left to right and decrease down the group. Everything is based on the power of the nucleus, the effective nuclear charge. That's what Jamb will always be asking you. Effective nuclear charge. That's the power of the nucleus. Then the other one is size of the atom. Let's look at it from the periodic table point of view. You have let's say we are using period 2, 2, 8, period 3 actually. Let's say this is sodium. Group 1, group 2, group 3, group 4, etc., etc. So this one have like this, you have 2 electrons. This one have like this, 3 electrons. This one have like this, 4 electrons, and so on and so forth. This one will serve for the rest. Now, you see the first group. We are talking about dealing with the size of the atom actually. The first group, and all of them have nucleus and the same number of shares. We are not concentrating the internal share. Remember, it's the number of valence electron that determines the group. This one have only 1 valence electron. Let's say the nucleus is pulling it from this side, it's shrink to this side, you see it becoming smaller. Nucleus is pulling it from two sides, so the size is now decreasing because they are all the same size. It's pulling it from three ends, you see it becoming smaller. This one is pulling from four ends, you see it. So before you get to the end, you are almost having something that is very, very small. So the size decreases from left to right. It decreases because of the number of electrons the nucleus is pulling in the same shell. So it decreases from left to right. Don't forget that. And as you go down the group, more shells are being added. You see it. So the influence of the nucleus on the outermost electron become weakened. It's no more effective enough to pull it because you are adding one shell. Just consider you here with somebody very far off. So this is how it is. Therefore, the size of the nucleus, the size of the shell decreases from left to right because of the effective nuclear charge, the pull of the nucleus on the outermost electron. The more the number of electrons on a particular shell, the smaller the size of the shell becomes. And if the size of the shell, let's say the shell is like this, and it suddenly becomes like this, what happens to the nucleus? The radius. The radius also becomes smaller. So as the size of the nucleus of the shell, the size of the atom decreases, the size of the radius also decreases. But how do you determine the radius? What is radius? Radius of an atom is the distance between the nucleus and the valence electron on the valence shell. Remember again, the size of the radius of an atom is distance between the nucleus and the valence electron on the valence shell. But in reality, that is by definition. Remember, the electron is always in motion, just like the planet are always in motion around the sun. The sun is taken as the nucleus, the electron is taken as the planet. It's always moving. And because it's moving, it now becomes difficult to determine the radius directly. Therefore, in order to determine the radius of an atom, you consider taking another atom of similar electronegativity value and then measure the distance of the two nucleus, because positive and positive charge they repel. Therefore, the both of them, where the repulsion is first felt most, is where we consider as the nucleus. You take the distance between these two, SS, where the like that become 2s, radius now become 2s over 2. You now have s, which is the radius of one of them. That's how I determine the radius. Cannot be determined directly because of the motion of the electrons. So the size of the atom decreases from left to right as more electrons are added to one shell, becomes shrunker because of the power of the nucleus to pull it to its effective nuclear charge, and it decreases down the size decreases from left to right and increase down the group because the power of the nucleus is no more very strong enough to pull it because of the greater number of shell that is being added. That determines this. This actually. Then the last one, which we are going to consider today, please note it very, very well. It's very, very important. Jamb is so some of their questions are funny. They will just write it and say arrange it in order of their increasing size. You look at it, the first one is sodium, followed by fluorine, followed by oxygen, followed by aluminium, followed by magnesium, followed by nitrogen. Before I go into this, let me just draw your attention to some other ones. Assuming you are given given an element and its ion, you look at it whether it carry a positive charge or a negative charge. For example, let's say I have sodium now. Sodium and sodium ion. It's not part of this. I just want to explain this to you before I go to the question. Let's say this sodium and sodium ion. They also have chlorine and chloride ion. Forget about the molecule, we know that. Now look at this, 281, 28. You see it? This one has 3 shells, period 3, 1, 2, 3. This one have only 2. Therefore, the size of a metal is smaller, is bigger than its ion, no matter the metal. If I have magnesium, the same thing, it has lost 2, so one shell is gone. The size of sodium as a neutral atom is bigger than the size of its ion because I lost one shell. But for negative one, you have this 287, 288. You see it? These 3 shells, actually, this one is also 3, but it is assumed that is bringing a stranger, a different one into it, making it to seem as if a different shell is added because it has brought another thing entirely. Therefore, the size of a negative ion is bigger than the size of its neutral atom. Cl minus, meaning that Cl minus is greater than Cl, while Na is greater than Na plus. Don't forget that. Then let's go to the question. The rule that governs this is this: as the atomic number, just know it, and that settles it for you. As the atomic number increases, the size decreases because of more proton that is being released, more electron is being released, and the more of the no proton actually, more electrons are being released, making the size to be reducing. Therefore, as the atomic number increases, the size decreases. So let's arrange in that order. This 11, this 9, this 8, this hydrogen, helium, lithium, beryllium, boron, carbon, oxygen. Oxygen is 8. Nitrogen is minus, sorry. This is minus, so not plus. This is 13. This is 12. This is 7. I don't even know carbon, nitrogen, oxygen. Okay. So it goes like this. Remember, as the atomic number increases, the size decreases. So let's see. He said, follow the rule. Arrange the following in order of increasing, not decreasing. So you have this one, the first. Al3 plus less than Mg2 plus less than Na plus less than F minus less than O2 minus less than N3 minus. You see this 13, 12, 11, 9, 8, 7, 7, 8, 9, 10, 11, 12. So this is increasing order. Increasing order. In some of your objective options, you may have the other way around. That is why you have to be careful. After understanding it like this, you don't need to fail the question. You have to check it and be very sure you understand. He said, arrange the following in order of increasing size. And remember, as the atomic number increases, the size decreases. So this one is the highest here in terms of atomic number, therefore it has to be the lowest in size. That's all we can take for today. God bless you all. As you continue to watch my video, please kindly subscribe, and God will continue to bless you. Shalom.